Good evening, students. Welcome to the class of Technomathics. So today we'll be taking one question from calculus, and the question is basically from differentiation. Okay, where the question is tan of x plus y is given to you, right? And we need to find dy by dx of this, right? You need to differentiate it with respect to x, right? So into this question, what we will do? Let us see. Okay. The y is given to you as tan x plus y, right? This is y. Now we need to find d by dx. We need to differentiate this y. Then if we are going to differentiate this, then definitely d by dx will be applied to both the sides, right? So here into the RHS also it will be applied to tan of x plus y, right? But to differentiate this, you can see the tangent of x plus y is given to you, but we are having we are going to differentiate it with respect to x. So for the functions, the if the tangent of x was only given to you, then it was very easy because differentiation of tan x with respect to x d by dx of tan x is sec square x, right? But here it is not like that. So instead of x, it's x plus y. So how to solve such questions? You need to understand what we are going to do. Since the tangent of the function is into the form of x plus y, you can see. So that's why this x should not be here as x, but here it should be x plus y. Okay, this should be into the form of this x plus y, right? So what we will do, we will just differentiate the RHS. Let us see what we are doing, right? The RHS can be written as d by d of x plus y, right? This is introduced. Then we can write tan of x plus y, right? Since d of x plus y is introduced into the denominator, we have to write d of x plus y into the numerator, and earlier it was dx. So this will coming here, right? So what is done here, we have introduced these two terms, d of x plus y here and d of x plus y here, right? Now the RHS will be, since we are going to differentiate the RHS with respect to x plus y, then tan of x plus y, we know that tan of any function, then differentiating it with respect to that variable will be sec square. So tan of x plus y and d by d of x plus y for tan x plus y will be sec square x plus y, as it is. Now here you can see d by dx of x plus y. So d by dx of it will be multiplied with d by dx of x plus y, just split it, d by dx of x plus d by dx of y, right? Is it fine? Now d by dx of x and d by dx of y. So d by dx of x will be 1, right? So right here, here you can see sec square x plus y is multiplying to both of these, right? So this will be coming into this bracket, right? Now we simply shifting it a little up, okay? Then we have sec square. Hi narrator Kun, can you tell me which class is this? Yes, class 12th. Sec square, this is from class 12th, okay? Yeah, you can see it's basic, okay, but this question is coming into Punjab University in earlier years, in 63, 79, okay? So I've just picked this question from there, right, Vaishnavi? Yeah. Yeah, for JE this will be advanced, no, not advanced, this is a basic, Okay, but you need to understand how to solve differentiate these questions. Okay, so let me proceed forward. Okay, so sec square x plus y will be outside the bracket, and we have here into the bracket d by dx of x will be nothing but 1, right, plus dy by dx, right. Now into the LHS we have already dy by dx, right, which is already coming from the LHS. Now here you can see the dy by dx of LHS will be as it is, and into the RHS just multiply sec square x plus y with this one. Then we have sec square x plus y, right, plus dy by dx of sec square x plus y. So we can write sec square x plus y because this is acting as a constant for the term dy by dx, right. So here I think you can understand this dy by dx, this is coming into the RHS also, and this is here into the LHS also, right. So what we will do, we simply push this dy by dx to the LHS. Okay, this term will be pushed over here. Then what we will having, we will be having dy by dx minus sec square x plus y into dy by dx, right. Let me push it a little up, right, and this is equal to sec square x plus y, right. Now when dy by dx is taking, as we are taking common this dy by dx from both these two terms, then we have into the LHS dy by dx of 1 minus sec square x plus y, right, and into the RHS we have only sec square x plus y, right. Now here you can see 1 minus sec square x plus y and dy by dx and sec square x plus y. So what we will do into the next step, this dy by dx is kept into the LHS like this, and the terms associated with it into the LHS, this will go to the denominator of RHS, and here we have sec square x plus y, this will come to the RHS denominator, into the denominator of RHS. So this will be like this, right. Now what we will do, sec square x plus y can be written into the form of tan square x plus y. How? Because sec square x minus tan square x or sec square theta minus tan square theta is 1. Do you remember this relation? Sec square theta minus tan square theta is equal to 1, right. So here, hi Archana, hi Vernoron. Yes, you are right. You perfectly caught it. So this relation is known to us. So from here, we can write sec square theta as 1 plus tan square theta. Sec square theta can be written as 1 plus tan square theta. And this relation we are going to use where? We are going to use over here. Why? I will explain. So when this will be used into the above equation, above dy by dx format, then we can write dy by dx can be further simplified as 1 plus tan square x plus y, because here into the numerator we have sec square x plus y, right, and sec square x plus y can be written as 1 plus tan square x plus y. So we have just simplified it. Sec square theta can be written as 1 plus tan square theta, and we written it like that. And into the denominator we have 1 minus sec square x plus y. So just write it the same way. 1 minus, instead of this sec square x plus y, write 1 plus tan square x plus y. So here there is some power disturbance, so don't worry. I think it's visible to you students. Hi Parody Edits Maths. Yes, you are right. Perfectly caught. Now here you can see, since into the question it was given at y is tan of x plus y, right? Y is tan of x plus y. So we can write, instead of tan square x plus y, you remember this into the question, because it was given that y is equal to tan of x plus y into the beginning. So that's why we can write it. We can write tan of x plus y as y. So it is 1 plus y square, because here you can see this is square, right? Yeah, Vanoron, Dorazio, Drozario. I hope I pronounced your name correct. Let me know if I am right. So parody, okay. So and into the denominator also it will be 1 minus tan square x plus y will be equal to same as did into the numerator, it will be y square, right? Okay. So here you can see this 1 and 1 will be cancelled out, and we have 1 plus y square divided by y square, and this minus will be remaining here, and this will be the value of dy by dx. Okay. So students, I think you find this solution useful. So as usual, into the last, which I am showing to you how the steps have been written, and how I will show my entire solution in front of you at the last. So this will be like this. Let me show you. So in this paper I just started, and this was the question. The question was that since y equal to tan of x plus y, we need to differentiate it with respect to x. So being an implicit function, what we did, d by dx of tan of x plus y will not be happening, because you can see this x plus y, okay, and with respect to x we need to differentiate, so it will not happen. So that's why I mentioned this, that this can be only differentiated with respect to x plus y only. So that's why here d by x plus y, in the denominator you can see d of x plus y is inserted, and here also it multiplied, one into the denominator and one into the numerator, so that if we can cancel it, the things will remain same as into the previous step, right? Now from here, tan of x plus y, d by dx plus y, for tan x plus y will be how much? It will be sec square dash, right? Now we can see d by dx of x plus y is left. So d by dx of x plus y is nothing but d by dx of x plus d by dx of y, right? And here into the LHS dy by dx is already there. Now into the RHS we have sec square x plus y as a common. So we just write it like this, right? And into the bracket it will be d by dx of x. So d by dx of x will be nothing but 1 plus dy by dx, right? Into the LHS we have dy by dx, and into the RHS we have sec square x plus y multiplied with this 1, and this will be sec square x plus y plus dy by dx times sec square x plus y, right? So here you can see the dy by dx is present over in here into this term into the RHS, and even it is present into the LHS. So just push it to the RHS. RHS term with dy by dx just could be pushed into the LHS, and we have into the LHS dy by dx. So When it will be coming into the LHS, it will be dy by dx minus sec. This is the term from the LHS which just arrived into from RHS, which is derived, right? And coming into the LHS. So we have dy by dx equal to 1 minus sec square x plus y, dy by dx into 1 minus sec square x plus y equal to sec square x plus y, right? Which is further written as, when this term will be coming into the RHS, into the LHS, we have only dy by dx, you can see. So only dy by dx can be written as sec square x plus y by 1 minus sec square x plus y, right? So we are just remember a relation, sec square theta minus tan square theta is equal to 1. So from here we can write sec square theta as 1 plus tan square theta. So we will be using this relation. We will be using this relation, and that we did over here. Into the above we have sec square x plus y. So instead of sec square x plus y, we have written 1 plus tan square x plus y using this relation, this one, right? So, and into the denominator also there is a sec square x plus y. So we just replace that sec square x plus y with 1 plus tan square x plus y. So we have the question given that y equal to tan of x plus y. So that's why instead of tan x plus y we have written y, and a square is already there, so that's why 1 plus y square will be into the numerator, and into the denominator it's 1 minus 1 minus tan square x plus y. So instead of tan x plus y, again we into the denominator we have written y. So and one will be cancelled out, you can see here, right? And finally we get the value of dy by dx as minus 1 plus y square by y square here. So this is the answer, students, and in this way we have differentiated the tangent of x plus y, okay, and we have find the value of dy by dx, right? So in this way we have solved this question, students. For any doubt you can put up into the comment box. Hi Arna, hi Veronoron Rosario, I think it would find it useful. Hi Parody Edits, you find it useful, I hope. Hi Vaishnavi, I think you find it useful. Hi Naruto Kun. So this is from class 12th and I think you find it useful. Just be connected and I will come up with separate sessions with on the calculus questions as on demand. It was asked to me, so I tried to bring it. Okay. So this will just concept building questions and this will definitely help you out. Okay. Thank you so much for watching. Keep connected. Bye bye. Take care. See you.